Fill in a blank to correctly complete the sentence. The function g of x equals the square root of x has the range. So here is the function. Okay, so first let's take a look at the function and determine what is the domain and the range. Okay, so remember that the domain is going to be all the x values that correspond to this function. And the range is the output, which is g of x, which is equal to the square root of x. Okay, so let's just go ahead and plug in some numbers. If we plug in 0 for x, okay, that means that the square root of 0 is going to equal 0. Okay, if we plugged in 1 for x, the square root of 1 is going to equal 1. If we plug in another perfect square, 4, the square root of 4 is going to equal 2. So when we think about this as a domain and range, okay, we have an ordered pair. The first ordered pair is 0, 0. The second ordered pair is 1, 1. The third ordered pair is 4 and then 2, and then so on. Okay, now so far we plugged in all the values for 0, 1, and then 4. Now what happens if we plug in a negative number? If we plug in negative 1 for x, the square root of negative 1 is not a real number. Okay, if we plugged in, let's say, negative 4, again, the square root of negative 4 is not a real number. So now if you look at these ordered pairs, the domain starts at 0. And the range starts at 0. But you can see here the domain goes from 0 to 1, 1 to 4, but it could go from 1 to 2, 3, and 4. You can see that the range also goes from 0 to 1, 2, and so on. So what would the domain of this function look like? Well, the domain of this function means that you can plug in any values for x that's greater than or equal to 0. And so therefore, we would say that the domain of this function goes from bracket 0 to infinity. Now, what is the range? Well, the range is all the y values, or g of x. And if you saw here, we started at 0 as well. And that means we're going to get the same thing. It's going to go from bracket 0 to infinity. Okay, now let's take a look at what this graph would look like so that we can see how it matches with what we just did algebraically. So I'm going to open up Desmos and I'm going to put in the square root of x, and then I want to see what this graph looks like. So I'm going to go ahead and just copy this graph into my notebook here, and then we're also going to take a look at that as well. Okay, so we're going to match the graph and determine what does it look like as far as finding the domain and range of this graph. Okay, so let's take a look here. So the domain, right? Remember the domain is all the x values. So all the x values. Now you see this graph starts at 0 and it includes 0. So that means it's a bracket. And then it continues to the right and it goes on forever. So you have bracket 0 and it's going all the way to positive infinity because this graph is continuing. So you can see here that that's going to match the domain. Okay, now let's take a look at the range. Well, again, the range is going to start, it's all the y values. And again, it's starting at 0. And this graph keeps going up and up and up. And so therefore, there is the range. Okay, so you can see here that this represents the range of that function. Now let's go ahead and put in our answer. So we're going to put in bracket 0, comma, infinity with a parenthesis. Let's check our answer, and there is our result.